Main topic for today is just performing operations with functions, including power functions. We're going to talk about what does power functions actually look like. You know what a power looks like. So then we're going to talk about power functions. Between the next 2 days, we're going to be not only talking about power functions, but also function operations. Like, what if I wanted to add two functions, subtract two functions, multiply, divide two functions, or compose two functions? That's doing a function and then doing another function, composing them at the same time. We'll look more about that tomorrow. First thing is to get the rules down about operations of functions. This can be found on page 415 in your textbook. If you let f and g be any two functions, so we've got two functions here. F might be taking twice a number, or 2x. G might be taking a number and squaring it, x squared. A new function h can be defined by performing any of the four basic operations on f and g. If you can add f plus g, subtract, multiply, divide. Then we're going to talk about the domain of this combination. Consists of the x values that are in the domains of both f and g. The domain of a quotient does not include x values where the denominator is 0. We're going to get this in better details. Sometimes when we see a whole bunch of words, our brain just gives up. So we're going to see more examples of this. Let's get the definition down about a power function. A power function is in this form where you're going to have, well, we typically see a y equals, and then this a, we've seen an a before, the leading coefficient, a times x to a b power. A is going to be a real number. We won't be dealing with imaginary. And b is some kind of rational number. This could be a fraction, but it's x to a power. This is what a power function is called. So let's say you have the following. We're going to be adding and subtracting functions. We're going to let f of x equal 2 minus x and g of x equal 3x. So f's function is taking 2 minus a number, and g's function is taking 3 times a number. And we're going to perform each indicated operations and then practice stating the domain. I notice I'm going to take this function. Remember how f of x is a name. It's not saying f times x. I can't read it like that. That's incorrect grammar in math. If I see this notation, I have to think of it as a function. This function plus this function. I'm going to look at, all right, what is f of x's function? It's taking 2 minus a number. So let's put it in. The very first function, I'm going to use one color. So if you like using color, use color in your notes. I'm going to use purple for 2 minus x. For f's function. Do I need parentheses around it? Maybe not. Or maybe. I might leave them in there. And then I'm adding g's function. I'm going to use blue for g's function. This is what I'm doing. I want to see what these two functions are combined. So then adding like terms, what do we get here? I have a negative x plus 3x. And notice how I'm not distributing anything. There's nothing outside parentheses except a 1. So negative x plus 3x, we get 2x plus 2. Talk about domain for a moment. Are there any numbers that I cannot plug in? That's what you've got to ask yourself with domain. Are there any numbers that I cannot plug in? We look for denominators. Denominators cannot contain 0. So I look, okay, do I have a denominator? No. Do I, or square roots. Can't take square roots of a negative number and be a function. So I can't have a square root of a negative, but I'm not seeing any radicals here. In this case, domain is all real numbers. You could use a bolded R or all real numbers written out. In the next case, again, I'm going to use purple for the f of x, and then I'm going to use blue for g of x. I get negative 4x plus 2. That's those functions combined by subtraction. Again, domain, I'm looking for, okay, do I have any denominators or even roots? So that way I don't get imaginary numbers. And if I don't have either of those situations, domain is all real numbers. Most situations will have all real numbers, but not all. So I want us to see the reverse. What happens if we took g of x minus f of x? Would we get the same answer as before? So in this, using the same functions as before, I'm going to use blue for g of x. So if I took 3x and subtracted f of x, would I get the same answer? What do I have? Ooh, I got to remember to distribute that negative. So maybe I need to clean it up a little bit first. I have 3x minus 2, but then plus x, because that negative needs to distribute. So now I've got 4x minus 2. That's them combined in this order, g of x minus f of x. So domain, is there anything special? I look for denominators or even roots, and if I don't see them, domain is all real numbers. The last one is taking g of x and adding it to itself. So what if I wanted to double g of x? Taking 3x, adding it to itself. Get a total of 6x. Domain, there's not a denominator and there's not an even root. So again, in this case, domain is all real numbers. I can plug in any number into that x. I want new functions. So first off, we're going to multiply f times g. This is another way we could see. I could either write this as f times g, or some books choose to have the notation fg. Some notations, or some books like to do f of x times g of x. They all mean I'm going to take f's function and multiply it by g's. They all mean the same thing. Like, how would these look like combined? So f times g is going to be, all right, f's function, which is x to the 1/2 power, and then I'm multiplying by g's function, 3x cubed. Coefficient 3, and then I add exponents, 1/2 plus 3. That would be 7/2. That's their product. And then we've got to talk about domain. Here's the thing about domain. You're looking for denominators and even roots. You've got to ask yourself, is this an even root? And when I talk about even root, it's got to have an even index. If I rewrote this in radical form, we would have 3 times the square root of x to the 7th. Well, wait a second. Square root, an even root cannot have negatives under here. It cannot have negatives under there. So, with this domain, we've got to be careful. X cannot be negative. How do I represent that? X has to be bigger than or equal to 0. Note this special case. Anytime you have an even indexed root, the radicand needs to be bigger than or equal to 0. So like, let's say it said x plus 2 as this radicand. If x plus 2 was the radicand, I would have to say x plus 2 needs to be bigger than or equal to 0. If it said, I don't know, if it said 2x plus 5 in that radicand, then I would need 2x plus 5 bigger than or equal to 0. Whatever that radicand is. Let's multiply these and then check the domain. My bad. On example 6, if I'm multiplying these two, I'm going to have to distribute. I notice the plus sign. I have to distribute. So I notice I don't have any denominators or anything that has a fraction as an exponent, so the domain here is all real numbers. We need to be aware of that on homework because that's also on your quiz come Thursday. You have to recognize, okay, what is the ending function if you combined them somehow, and then identify the domain. So in the next example, not 8. Next example, changing it up again. We're going to take f divided by g, looking at f of x being equal to 4x to the 2/3, and g of x equal to 2x. So if I'm looking at f divided by g, taking f's function, 4x to the 2/3, and dividing it by that 2x, I have to figure out, okay, from yesterday's stuff, how do I simplify this? This was like that worksheet we did on Friday. I have to reduce the coefficients as, well, this will reduce to 2. So we get a 2 to 1, reducing, but then what do we do with the exponents? We would have, I guess I don't like writing my answer because a 2 over 1 is just going to be a 2. But then we have x to the 2/3 in the numerator, and then I'm going to subtract the denominator exponent. The denominator exponent is a 1. Wait, we have a negative 1/3. That means I need a reciprocal. So here's where we're getting really tough. So this is becoming 2 over x to the 1/3 power. This is their product. Or no, this is their quotient. So I need to be on the lookout when I'm talking about domain. I actually have both cases in this. In domain, not only do I have a root I've got to worry about, but I also have a denominator. First off, I got to ask myself, well, one of the first questions, do I have an even indexed root? If you change this into radical form, I would have the cubed root. Well, that's not an even root. So I actually don't have to worry about being bigger than or equal to 0. But I do have a denominator. Denominators cannot be 0. So if this was 0, that denominator would be 0. I'd get an undefined equation. So x can't be 0. It can be anything else except 0. In our calculators, that would spit out undefined. So we're going to look at this quotient again and try to figure out, okay, what happens in this denominator. F divided by g, where this function f is going to be negative 7x plus 1, and g's function is just going to be x. So f's function divided by g's function. This is the simplified version of f over g, or f divided by g. I'm ready to hit the domain. With domain, I look for even roots and denominators. Denominators can't be 0. Even roots have to be bigger than or equal to 0. Notice the denominator. X cannot be 0. So I specify that with the domain. A little note about domain. What do we do when? There are 2 things you need to be aware of, or beware of. Denominators and even roots. And maybe, shoot, let's get better language, and instead of roots, I almost want to put indices. Even indexed roots, so maybe not cross that out, maybe just add in. Even indexed roots. So verbatim, by the way, this word's going to go away in a little bit, like right now. So first off, denominators can't be 0. Denominators can't be 0. And even roots can't be negative. Stuff. Sneaky stuff. So I want to put these sneaky examples up here. Because sometimes whenever we don't see it in its denominator form or its even root form, sometimes when we don't see it, we don't think it's there. But these are sneaky examples. Okay. f of x equal to x to the negative third. We need to be aware that, wait a second, if you have a negative power, so it's written as a power function, if it has a negative power, that can be rewritten as a reciprocal. 1 over x to the third. And then, hey, wait a second, now domain really pops out at me. That denominator can't be 0. Notice how I say the words can't be. And look at the symbol I write. Those go hand in hand. In the next one, so we have x to the 5/6. When it's not written in radical form, I really don't know if I have an even indexed root. So I'm going to change g of x to be rewritten as 6th root of x to the 5th. Now I see that even index. Now I need to realize, okay, domain, that radicand x can't be negative. So it's got to be bigger than or equal to 0. So when I say can't be negative, oh, you can't even see that written. Can't be negative. That means it's, oh, you can't even see that written. But you can't, this says can't be negative. I should pay my bill.